is not just about building technology. It's about reimagining the future and having the courage to bring it to life. And our guest here has been someone that has been doing the ETSAT for the past few years. He has been playing a defining role in shaping India's electric mobility journey. He is the co-founder and chief technology officer of Ather Energy, one of India's leading electric vehicle companies. While over 10 years of experience in the electric vehicle sector, he leads Ather's long-term technology vision while nurturing a robust engineering team and a culture driven by innovation and excellence. An alumnus who holds dual degree in engineering design. His contributions have earned him the Young Entrepreneur Award from the AIMA and recognition in Forbes India 30 under 30 in 2018, as well as Fortune's 40 under 40 in 2019, 2021, and 2023. Ladies and gentlemen, please join me in welcoming Mr. Swapnil, co-founder and CTO of Ather Energy.
Hey, good evening, everyone. So I will try to not have a presentation, but more about a free-flowing conversation, more about our journey, and also talk a bit about what we learned in the journey. I'm assuming some of you are here for the tech, some of you are here for the entrepreneurship aspect of Ather. Along with that, I'll give enough time for questions. I think that would be more helpful than me telling my story rather than answering your questions. Okay, so a brief background, if you don't already know. It's two of us, Tarun and me. We graduated in 2012, IIT Madras. You know already that engineering design, and we were classmates, and a large part of our first of our journey at the campus was just about building products. We accidentally landed in Department of Engineering Design. Most of us actually did not know what it meant. What does the department do? I don't know how many of you still know what the department does, but I was chatting with few people outside and realized they also accidentally landed in ED. So that seems to be continues to be the case. So we landed there, but it was I think the best serendipity of life. That first of all, both of us came together, and the entire department as such was very much about product development. So I mean, as young engineers or like just joined engineers, or students, you barely know a difference between product development and engineering. I mean, you think engineering, product development, and honestly, not just you guys, like many people even outside don't understand the difference between engineering and product development. It sounds similar. Many people call product development as R&D, but I believe that they are two very different. How many of you know difference between engineering and product development? Or if I'm not going to embarrass anybody, but if you want to take a stab at it, go ahead. Okay, fine. I know the mood of the crowd. So the biggest difference is in engineering you are only solving physics, but in product development you are actually solving problems of customers. I mean that's the biggest difference. If you only design a beam, that's engineering. You can always design a beam, but did that beam design solve any problem for the end customer? If yes, then that's what is product development. And I think it took a long time. Maybe it took almost up till graduation for us to understand the difference between engineering and product development. In engineering, you only care about physics. In product development, you care about cost, you care about manufacturability, you care about serviceability, you care about what the customer likes, and you'd be surprised that you could build the best engineered product out there, and still customers will not buy it. And we almost had at that sort of a moment that when we built our 450, it was an amazingly engineered product, but there was a very a small segment of the market which actually wanted it. So we realized very late that the biggest factor in people choosing an automobile is about how it looks. You can get everything right, but if you don't get the if you get you can get the best of the engineering there, the finest of the engineering there, but can we switch off the projector? I don't think they know who. So you can get the best of the engineering done, but if you don't actually meet what the customers are looking for, then all your engineering is of no use. So when we designed the 450, we realized that not more than 15% of the scooter buyers actually want to buy a sporty looking vehicle. They all wanted to buy a bulkier looking Activa sort of a product. So that's the big difference between engineering and product development, and we started learning a lot about that in our early days of ED. Um, Also, what happened is those were the early days of C5. This C5 was, I think, just got inaugurated when we joined IIT, or maybe a year later it got inaugurated. And again, that created another serendipity, that it created the culture of student-led projects. Before that, there were not many student-led projects which were happening. Most of there were research project, academia projects which were happening, but nobody was participating in any competition. Not many people were participating in any competition. Not many people were building like products with their bare hands. And there's a ton of a difference between trying to build like trying to design something on paper and then trying to build a product, a physical product. And that is a, and you understand a lot about reality of engineering when you start actually building things with your bare hands. We were very lucky. The C5 started in that time frame, which got us to participate in things like Raftar. We were the first team to actually like drive a vehicle on the circuit. So from IITM. So that was again a great experience. So these two things put together created a very conducive environment for us to do product development. Along with that, another thing was happening, which was this e-cell C-tides, which was emerging, and the interest around entrepreneurship was also sort of starting to sort of come up in the student community, and uh, and Tarun was more involved with C-tides, though he was also very much there in the product development, but he was more leaning towards C-tides and e-cell. So now that gave us another exposure towards startup ecosystem, VCs, business plan, and those things. And we actually also enrolled in a minor of social entrepreneurship, which again sort of at least got us to talk about terms like business plan and financials and product development and and things about taking a product to market. Like those very early days of trying to build a product, actually we would go talk to customers, trying to understand what are their problems, are we solving their problems. So whatever happened with the project, but I think there are a lot of learnings which came from there, which which helped us in the journey to build Ather. So those were the early days. Then we after all these exciting 5 years at campus, we we finally decided that okay, we actually tried a couple of things in the campus as a product and as a startup, but it was too difficult to take them to any kind of maturity. So we just decided, okay, like we had good fun, but we are going to go back to, or rather, we are going to go and take a regular job. So I took a job in one automotive company. Tarun took a job in another automotive company. I was in Bangalore. He was in Chennai. and it only took us 4 months to realize that corporate is very boring. Especially, I mean, not all corporate is boring. Either is not boring, but but what we realize is that especially if you are in a in a in an organization which is not very attuned to product development and engineering, then you will then it was not for us, like, because we were hardcore engineers. We I mean, like, we, at least I was very clear that I don't even want to take a non-core job. I want to take a core job, because otherwise I felt like what did I do with 5 years of learning engineering if I'm not using it for product development or engineering as such. So it was a very honestly a very sad moment back then in 2012 for India, because there were barely any companies which would do any real engineering. Most of it was back office job. Like, you will have glorified OEMs who would primarily do very back office work, like run some simulations, do some CAD model, or do some application engineering sort of a work, which wasn't very interesting. It was not real product development. It wasn't real engineering, and definitely it did not require IIT skills to do it. And so it took us 4 months, and we were like, yeah, this is not happening. We are we still have the itch to build something, and this is not solving for it. So one fine day, and meanwhile, what we also realize is that uh, battery prices are falling sharply. The EV tech is becoming mature, and we just, I mean, like, because of one of our class project, we got exposed to EVs and batteries and all of that, and so it was Tarun's project, and he kept on sort of reading more about batteries and EVs in general. Um, and then one fine day, he just told me that, hey, I think we can build batteries for electric vehicles, and it perfectly makes sense, and few years later it will become a big thing. And then I did some research, and I said, okay, let's batteries are interesting, but what if we just build a vehicle itself? And the thought process was actually very simple. That when back in 2012, if you look at any two wheeler, electric two wheeler, there was no engineering. There was absolutely no engineering, because most of them, actually 100% of them, were bought from China, assembled in India, and sold. There was no engineering actually being done on those vehicles. And if you ask somebody why not, and most of them were like lithium ion, low speed, like you'll go barely 30 35 kmph sort of a speed, only lead acid batteries. And if you ask somebody why are you not building high powered vehicles, the simple answer would be that it's too expensive. But when we looked at it in depth, we realized that it's the people who are telling you it's expensive have no idea about what the technology is going in. They just ask for some quotation from some Firang company, and the Firang company gives them some inflated quote with 100% gross margin, and they think that, okay, it is that's why it's expensive. But if you now go into the nuts and bolts, actually you apply first principles pricing to the costing, you realize it's not even half of what these guys are telling you it would cost. And that was our moment, that we said that, hey, people are like not being smart here, and they are just because they are not engineers, they don't understand what it takes to build an EV, and they are getting ripped off in the name of pricing. So if the best way to build an best way to make EVs popular is actually to build the entire full stack of electric vehicle. Uh, Also, because most of the work happening across the globe was on four wheeler. Nobody was interested in building electric two wheeler. No country in the world uses as many two wheeler as we do. So nobody had the need to do any kind of innovation on electric two wheeler. So all the technology which were available were very much like a four wheeler technology. Just to give you a simple idea, a charging connector. A charging connector would cost, if you buy a four wheeler charging connector, it used to cost like 5,000, 7,000 rupees just for the connector. And if you think about putting that on a two wheeler, 5,000 rupees, 7,000 rupees for a connector, that's just criminal for a two wheeler application. It's also very bulky. So and there was no standard for electric two wheeler charging connector. So many such things we realize that there is no engineering done for a two wheeler which is very cost conscious, which has very different needs of its, and also nobody can actually do it because most organization, including the big OEMs, aren't actually doing product development or aren't doing any kind of hardcore engineering. They're mostly doing they're mostly buying components. So if you go into the supply chain of a two wheeler, forget about electric, but like a regular IC engine two wheeler, nobody actually designs anything except the engine and the chassis. Mostly engine and chassis is what is designed. Everything is designed by some other company, which the OEMs buy it and just assemble it. So the the uh, the thought of building a full stack technology for EVs was not something which was even organizations were not even structured to think in that manner. And that's when we realized that as this is the best place for a startup. The technology is advancing. The incumbents are not capable of building a full stack completely. Uh, there's a huge disruption which is coming in. That's where startups typically thrive. The startup won't thrive in a sort of steady state environment. Only when there is a disruption that gives a chance for a startup to sort of come in. So this was the best disruption which was happening, and we wanted to get into that, and that's how we got started with Ather. So that's the background of Ather. Uh, Yeah, I think a couple of things more. I think one of the things which definitely helped us is a kind of support we got from our professors. When we came in, we got Professor RK to give us some money to actually start building the vehicle. And Professor Sandeepan also gave some lab space to us, and the incubation cell helped us with more office space. So all of this put together actually created again another environment for us to actually take the plunge and actually start building Ather. So what next? So okay, we decided to start Ather, but now comes the entire journey of understanding the entire ecosystem of the country. We realized first that the earliest realization that was that talent does not exist. You have you have good engineers. First of all, a lot of the engineers have anyway are not doing engineering. They've gone into something or the other, but engineering. So most of the smart engineers, capable engineers, are actually not doing engineering. Second, you realize that even if they are doing any engineering, it's a incremental engineering which they are doing, which means that if you already have a product, how do you make it cheaper? How do you remove some mass from it? How do you sort of create some small feature into it, which is incremental engineering, what do you call a brownfield sort of a project. But nobody has any idea how to work with a clean slate. If I tell somebody, hey, design a charger, just it. If I just tell them you design a charger, nobody knows how to design a charger completely grounds up. How do you even write a spec sheet for a charger? Like what all does a charger need to do? Most people in the country did not know how to build it. Even if they could write it, they only could understand again, as I said, the physics part of it. They would put some resistor, some capacitor, some MOSFET, some microcontroller, uh, and then put it on a PCB, and then and then you realize that if you want to actually productionize that, it will cost you like 20,000 rupees just for the charger, right? Because they have chosen they have not thought about supply chain. They have not thought about manufacturability. They have not thought about end of life of some of the components. So just they went into some DG key Mouser, downloaded some resistor capacitor, put it in place without any thought into it. So product development is is a lot beyond just engineering, but we didn't have many such people. But the good thing is we had a lot of passionate people around us. Some of us, some of our friends, some of our juniors from campus, some our seniors from campus, who all were very passionate about trying to build something, and we said that that's the set of people we are going to start with. So I mean, like when the first product, the 450, which we launched in 2017, 2018, at that time, most of the team was less than 5 years experience. The engineering team, like that's it. Like nobody was having any experience more than 5 years in the entire organization, and and actually that was good and bad. Good because they didn't know what cannot be done. If you ask a more tenured engineer, they will say this cannot be done, that cannot be done, and or a more tenured industry professional, they will tell you why something cannot be done. But because these people didn't know why something cannot be done, they were willing to try it out and do it. So that was a good thing. The bad thing was they did a lot of noob mistake, which sort of made the price of the product or the cost of the product very expensive. It was very expensive to manufacture it. We are making it at 3 lakhs and selling it at 1 lakh. So every product was losing 2 lakh in it. At the same time, manufacturability was very difficult. Like to assemble one vehicle, it would take us like a half a day to assemble just one vehicle. And just to give you an idea, today one vehicle is built out in 1.2 minutes. So that's the difference which was there between what we had to be and what we wanted to be. So, but that's the thing. So having passionate people around you actually gave us that kind of a comfort that when we said, okay, done all these mistakes, and now we have to go and now design second generation of the product. All the same set of engineers who are less than 5 years experience could now design a product which was cheaper than what most of the industry could design, because they were smart, they were first principle thinkers, and now they had learned what not to do. The second generation itself was amazingly cheap than what most of the international standards would be, and till today it is our like even today the second generation of product is very 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 reliable on the road. So even the first generation was reliable, but it still had some of its challenges. But the second generation was a very reliable product put out in the field, but just by engineers who were about 5-7 years experience. So and that's the power of having the right kind of people in your team. So yeah, non-existent culture, non-existent talent. There was large dependence on the ecosystem itself. Like the thing about hardware is that you can't build all by yourself. You need ecosystem. You need suppliers, somebody who will make things for you. You can't make everything yourself. So you need somebody to give you tires, somebody to give you suspension, somebody to give you brakes, and somebody to manufacture your frame, because typically it doesn't make sense to make everything yourself. You should design everything yourself, but manufacturing everything yourself does not make a lot of sense unless it has a very high implication on the IP or the quality of the product. So we had to convince a lot of ecosystem players, and again that was very difficult because yeah, like you go and tell like we used to have funny incidents where we would like walk into a brake supplier and they have no idea who we are. Like they are thinking, okay, like they were expecting some okay, CTO or some CEO is coming, and then they're expecting like some really like suited people with like 50 years age is going to come in, and then we are turning up there like 25-year-old kids, and then they just couldn't comprehend what is happening. They couldn't figure out this is legit or this scam. So yeah, it took a long time for the ecosystem also to warm up to the idea that okay, fine, like just a bunch of kids out of college can build a full-fledged vehicle, and not just design it, manufacture it, put it into the field, and give amazing performance. So we had to break a lot of ceilings in terms of like distrust in the ecosystem. This is not like software industry is used to startups. They understand like a college dropout building a company, but hardware first of all doesn't even have startups. Like more so automotive. Like there like before Tesla came in, there was no concept of a automotive startup. So these people are not used to startups. These people are definitely not used to automotive hardware startups, and they have been asked to support us. So with a lot of skepticism, they did support us. Some of them were more interested. Some of them were less interested, and that was a journey to make for us. It was tough time, but I think that also gave us a lot of learnings. Sometimes you feel that like when you work with some ecosystem players, you feel that they are being too stubborn, but you have to then over a period of time you also realize that their stubbornness is coming from practical aspects which just as engineers you would not understand. They knew about product development before we started understanding it. So uh, so that's the ecosystem which had to mature for us. Same went obviously with customers as well. The customers also had to accept vehicles built by young engineers. Firstly, there is a barrier of EV, then there is a barrier of startup, and then there is a barrier of young engineers trying to build an EV. But it was very heartening to see those first few set of customers actually buying our first set of vehicles. I mean, they had to actually like work with us. Some of the times the vehicle would have some issues. We had to go and fix those. But a lot of them were very very excited. They were uh, those early adopters. We were lucky to have those early adopters because that's what helped us spread the word of mouth. You don't buy a vehicle just by looking at its spec sheet. You mostly buy a vehicle by the word of mouth, which spreads along. You will always ask for people what is a better scooter or better vehicle or better car or whatever, and only then really buy it. You will never buy it only based on what is the marketing document telling you. So those are the people who actually helped us build the ecosystem. Sorry, the word of mouth as well. And the biggest struggle in all of this for us was getting funds. So even today, hardware startups are very difficult to get funded because the gestation period is long. Most VCs want to see a return of investment, or at least a revenue. Forget about return on investment. They want to see revenue coming very early. But the hard truth about hardware startups is that revenue takes time. Like it would take you probably 4 years of product development before a revenue starts coming in. In a software world, probably that revenue starts coming in the first year itself. So, but that's also thankfully that can also work as your strength, because you know that it is so difficult to build a hardware startup. You have to leverage it. You have to do it right so that the next person who comes along is going to be that much more difficult for them to also build it. It's going to be for them also. It's going to be take 4 or 5 years to build the next the hardware next product in your domain. Yeah. So funding was incredibly difficult. Very honestly, until the IPO, it was a very difficult journey for us, because there has been a lack of trust on uh, again a young company coming in this very competitive world of giants and making a mark and being profitable. So but we were lucky to find the right kind of investors along the journey. It definitely wasn't a easy thing for us. It took a lot of convincing. It took a lot of proving to actually get somebody to invest in Ether. And the good thing was, finally, whoever came in were uh, were the long-term investors. So the one thing which is very important is to find the right kind of investors. you could have money. Many people might be willing to give you, but you also need to understand what are their motives, and do their motives align with what you want to do as an organization. And most of us in the early stage would not think about it. If somebody willing to give money, we will just take the money. But that can really sort of have an impact on your long term plan, because if your motives of building the organization and the VC's motives are not aligned, then they will sort of they can pull you in the wrong direction. If they want exit in 2 years, or if they want you to hit revenue in 2 years, and your product itself is something which cannot be developed in 2 years, how are you gonna get that sort of a thing? And then they'll start having building the pressure, and you would not be able to figure out how to get out of that. So finding the right investors was also a struggle, but I think we were lucky to get those. Even though it was tough, when we found them, we found the right ones, and I think that was very very critical. Um, yeah. So now, I mean, finally, what does it take to build especially a hardware startup? One what our learning along the way has been that you need a lot of patience. It is not something unlike a I mean, even startups, even software, depending on how deep tech it is, they also need patience. But hardware definitely needs a lot of patience. There will be a lot of times when things will not look easy, but I think those are the times which matter the most. If you are persistent in that phase, that's what really matters. That's what sort of differentiates a successful startup from a failed startup. Don't be too eager to pivot, and just because you're impatient. So patience has been a very very critical thing. Another thing which has been a big learning for us is that you have to balance a lot between, especially if you want to build an organization. So I was just talking to somebody outside and telling that even if you are starting up, you can start up in many which ways. That you can start up to just build a piece of technology. That's a lot easier. You build a technology, and you just sell the technology to somebody. Somebody will buy the technology from you. You take an exit. You made some money in the process. That's one way to do it. Other way to do it is you build a product where you not just the technology, but then you look at the end product which you want to build. You actually build the product. You convince the customers. You probably do some sort of a sale as well, and that's about building a. That's the other way of doing a startup. The example of first. mm, Okay, it doesn't come to my mind very quickly. If I think about something, I'll tell you. But yeah, so that's the second way of doing a startup, and the third way of doing a startup is actually building a full-fledged organization, and that's a real tough part. You could build a technology, you can build a product, but building an organization is equally difficult and a complex a problem as is building the technology. When you're building a technology, when you're building an organization, you're building product, you're building technology, you're building product, you're building the sales engine, you're building the after service engine, you're building the entire people ecosystem in yourself. You're building a brand, and hence you have to think about a lot of things when you are building an organization. And we were very clear from the start that we are not here to build a technology and sell it off, or just to build a product. We want to build an organization which will build multiple products for decades to come. And that's where a lot of decisions in terms of long term and short term thinking comes into picture. You could take a lot of decisions which will hurt you you have to take a lot of decisions which will hurt you in the short term, but which will help you in the long term. And many people do that mistake, that they take the the easy path in the short term, which start becoming a really difficult thing to sort of navigate in the long term. And like one of our peers in the industry has gone through the same struggle, that in the short term, even though they knew that the product had defects, they still kept on putting the product in the market, and soon the issues in the product became so overwhelming that servicing the product became very very difficult for them. We had many such instances where we would identify a defect in the factory, but then we would take that call that it's better to fix this defect immediately rather than send out these difficult defective products into the market, which could become a very difficult thing to handle. And those lot of these small trade-offs between short-term wins and long-term wins are the ones which made us possible to continue to be successful in the long term as well. So yeah, these were some of the key learnings in the process. And yeah, building a startup, while on the face of it sounds very exciting, beyond the point, it is again doing a lot of boring things, lot of things which you would not want to do as engineers. But if you want to really build a startup, and if you want to really build an organization of a startup, then it is a lot of boring things, supply chain, HR, legal, finance, all of those things which probably as an engineer you will not like, but are very 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 critical. Even boring things like systems, processes, all of that, which you now don't like as an engineer, but unfortunately without that you can't really scale up. You will fall flat if you try to scale up without all those boring things. Yeah, I mean that's sort of the journey and the learnings which I want to share. If you guys have any specific questions, I can probably answer those. The only other thing which I want to probably slightly touch upon is we are at a very important phase in time, especially given the geopolitics situation. We are in a completely opposite scenario which we were about 10 years back. 10 years back, everything was about globalization. Everything was, hey, let's don't do anything, just outsource everything, let the manufacturing happen somewhere else. Every country will start becoming their own expert in one area, and everything was globally. To the extent it's the supply chain today is so convoluted that that like to make one part, the materials flow around the globe to make that one part. This has led to multiple things. One, it has made a very fragile ecosystem, which we have seen with COVID. And when COVID came in, the entire supply chain came to a grinding halt. We had scenarios where semiconductors were not available, cells were not available, shipping like ships were not available to ship the product. So it was the one thing which COVID did is help us realize how fragile our entire supply chain ecosystem and general manufacturing ecosystem is. The recent geopolitical things, which I'm sure all of you are having a good laugh at, is also telling us something, that there is just too much reliance on few countries, and now everybody is realizing that, and nobody is and everybody is unhappy about it. And we are actually in a opposite trend now. Everybody is going to a Atmanirbharta sort of trend. Everybody wants to now bring things in house. We want to bring technology in house, especially given the country of our size and the growth which we are seeing. There is no way we can continue to grow this way by being reliant on China and the US and few other countries for everything which is required in the new world. You want AI, it's not there in India. You want semiconductor, not there in India. You want cells, not there in India. You want rare earth, not there in India. You want turbine engines, they're not there in India. So any new tech is not there in India, which is bad thing, but which is also an opportunity, for us to build a lot of these things. The simplest of the things which should be built in India are just not being built by anybody. So I feel that it is a massive opportunity to disrupt some of these established industries itself. Like some people are now building ACs, like reinventing AC in itself. So that's interesting, because somebody somewhere like 50 years back, somebody designed some AC, and probably just everybody just kept on using the same design and just evolving it. There was always incremental engineering which was happening. But did anybody go back and rethink how the AC for India should be? And also, please bear in mind that most of these technology were not developed for India. They have all of these have been adopted in India because it was developed somewhere else, and they just wanted India as a market, so they just kept on selling it in India. But very few things have been made for India. So if you can pick up the problem statements uh, for India specific, pick up any domain, understand what the origin of the product is, and understand if you were to design it for India, how would you design it differently? Well, I always ask this question. I don't even understand why ACs have a 16-degree temperature. Like in India, you are not used to 16 degrees, but most of the ACs, and we all sit in the theater, and maybe sometimes in the classrooms as well, shivering because somebody put the temperature on 16 degrees. I don't know why do you have a 16-degree setting on India air conditions. So so there are a lot of these opportunities which exist, and given the today's scenario where there is a lot of push from the government itself. If you have heard about some of these initiatives like ANRF, Anusandhan National Research Foundation, and which was granted about a 1 lakh crore fund, um, which is going to be used for uh, technology development in the country. So there is money, there is need, and there are definitely opportunities. So I think this is a good time to capitalize on all of those. Building that kind of a technology sovereignty in India is also very critical to continue the the kind of growth which we have. If tomorrow somebody can stop supply chain of magnets, cells, rare earth, semiconductors to India, we have nothing. Like we only have potatoes. So what do we do with those? I don't know. So we have to take care of these things, and in this geopolitical turmoil, I think we have a lot of opportunity to build. So I think that I would wrap with that, and happy to hear any questions.
Hi sir, I am Sagar. I am a final year master's student in civil engineering. I had a question. So in software startups, when the founder launches the product and when the early adopters are using it and doing some pilot runs, when there are some bugs, you can solve it through backend, you can solve it through iteration and finally the product. But in hardware products like Ather, when you were getting early adopters and doing your pilot runs, and if they found some issues, how did you tackle those? Like how were the iterations, or how did you tackle with those people?
Actually, very interesting, and that's a big difference between a hardware and a software startup. You can ship software. You can always do an update on it. Hardware startups, one, it's very hard to do update, and second, the consequence of a failed hardware can be very high. So one thing is, okay. So I mean, thankfully, we have. So there are two ways of tackling it. One is, first, you have to do a more uh, controlled launch. You shouldn't be launching all around the country at the same time and selling like 10,000 vehicles in your first month. Not just because you can produce it doesn't mean that you should be doing it. And even today, even after a lot of maturity, we still take that sort of a call that when we launch our product, we start slow. We want to see from the field what all issues can come in. A lot of the next is actually before this is thorough testing. Like you have to do thorough testing. You have to do a lot of alpha trials. You have to do on-road durability tests and all of that to ensure that most of your issues are taken care, but it will never be. It will never be. You will never be able to recreate 100% of the field scenarios in lab or in a controlled environment. You might have tested in Bangalore, but we realized that in one scenario everything was working fine in Bangalore, but the soil composition of Pune is different than Bangalore, and that led our problems with our belts. So those sort of challenges are also there. So controlled launch, then thorough testing, and uh, beyond this, the only thing you can do is have a good service ecosystem to be able to tackle these problems. One side advantage which we had was that from day one we had a capability of software over the air updates built into the product. So it gave us a massive advantage that if we found any hardware issue, we could actually tackle it with software. So a lot of our hardware issues we have been able to actually tackle with a software update. So that was a sort of blessing in disguise of sorts.
Uh, Hi, Swapnil here. Nice talk, and I'm a faculty here. I also work in the industry. I had two questions. Maybe you can choose to not to answer also. But on the Hero investment, right? They're a competitor. They have a good network and all. And when they invested in your company, what would their motive be? Is what I'm interested to know. Because your motives are clear. You wanted funding to sustain that runway thing is clear to me. But what would their motive be? Because if they're going to demand technology and that is going to cause significant challenges for you, what would it be? That is a prospect I wanted to understand. And the second one is on your thoughts on battery swapping, because Activas came with e-swapping. They're still in Bangalore, not come out, but what are the Ether's views on swapping and standardization of batteries for adoption?
So
Thank you.
yeah, so with Hero, the thought process was actually very clear. Uh, they were trying to build a hedge in their organization itself, because they knew that they are a traditional company, while they will attempt to build an in-house EV product. They always had the question, what if they fail? What if in-house efforts fail? And it was a very smart move by them to ensure that they at least have a decent stake in a company, which also increases their chances of success. They didn't know which will succeed. There was no guarantee that Ather will succeed. There was no guarantee that their in-house effort will succeed. But at least now you have two parallel efforts going on. Plus, obviously, as a startup, as founders, there is a different energy which comes in, which is very hard to bring in within the organization, within a corporate structure. So, so that was their motive. No, there is no technology. We were very clear from the start, and even till date, we have absolutely no technology transfer or supply chain sharing, anything of that sort. We work very independently as two different organizations. Our product strategy is different. Our technology strategy is different. Yeah, so we have no sharing of that sort. So that's on the Hero front. Battery swapping, we believe that it is good for fleet. If you have a fleet operation like a Swiggy, Zomato, or a Yulu, those sort of situations, they definitely make sense, because there you don't want to spend time charging. You want to just continuously keep running your asset. So, but for a regular consumer, there is no need for it, because most people firstly don't travel more than 30-40 kilometers. Like the extreme are usually like 95th percentile, if I look at it, is about like 30-40 kilometers a day. All EVs today can very easily do 30 to 40 kilometers on single charge, uh, and you can very easily charge it in the night. So you just come home, you plug it in, and by morning it is fully charged. So it's a lot more convenient experience to charge it at home rather than going to a swapping station. Then swapping stations are actually very expensive. That most people don't talk about that, because you have to sort of keep those many extra batteries to swap, and batteries are expensive. So there is a cost of inventory which you are carrying. Then there is a cost of operation. Your swap station, if for security you might have to put somebody. You need a real estate. So all of these things cost in for a swap station. So we have actually, when we started Ather, our first idea was to do battery swap. And then we later on said ki that's not going to happen. It doesn't make operational sense. We did all our calculation and we said no, it doesn't make any operational sense to do swapping, and just too complex a model for a regular consumer. It's too complex a model. Hey, I own the vehicle, but I don't own the battery. If I own the battery, then why is my battery given to somebody else? All of those questions come in people's head. So that's why we said it's too complex. It is too much of a change from how people in India don't even lease vehicles, right? Like we don't like lease model as well. We want full control, full ownership of the vehicle. So I think as an Indian ecosystem, we don't think swap works.
Hello, hello, sir. So I'm Arjun Gimire, and I'm also building my startup. And recently, I was also selected at Incubation Cell, IITM Incubation Cell, and I'm really inspired by the growth and the startup Ether is doing, and it is kind of an inspiration for all of us. So I wanted to ask, how does the growth looks like when you look back to past, maybe like 10 years back? What do you think? What was the good decision that you have made? What was the bad decision that you have made that made you reach here today, sitting at $1 billion valuation? So, what do you think? What was the best decision and bad decision that made you here?
Yeah, I think the best decision was to build the full stack of the technology, not taking shortcuts, and taking the hard way to build the product with all the technology on battery management system, like basically realizing that what is going to be uh, our moat, as we like to call it in the startup world, which is basically how do you protect yourself from either any other company to sort of beat you in your own game. So that protective moat was technology for us. We built put a lot of effort in building the team to build the technology. We went through a lot of hell of sorts, because it was not easy to build all these technologies under one roof. So we went through a lot, but now that we have come out of all that hell, we are very strong, and it's very difficult for anybody to sort of challenge us in those areas. So that was a good decision. Bad decision, I would say our first product, I think we complicated it a bit too much, and that was one learning that when you have to know your limits. I think as engineers, sometimes you might just get carried away. I will do this also, that also, that sort of a scenario. Just because it can be done doesn't mean it should be done. That's also a very important piece. That know what is critical, and only pick up that. So I think the bad decision was uh, we sort of, I think, overcomplicated our first product. We we did learn a lot from it, and eventually that became our strength. But it could have also very well led to our sort of collapse if we had not handled, if certain things would have not have happened, it could have led to our collapse. So maybe, yeah, that was not a best decision. That's what that's what I was saying. And okay, so one important thing is once you launch, things change. Like it's a before you launch a product and after you launch a product, there's a world of a difference, because once you launch, you have to start thinking about production. You have to start thinking about cost. You have to start thinking about service. You have to start thinking about backward compatibility. All of that you have to start worrying about. Unless you start the sales, life is a lot simpler. Once sales come in, it becomes very difficult to change anything from a running product. And I think that is why we took our time to ensure that what we start with is what we want, because otherwise it would be very difficult to change. Plus, also at that time, there wasn't, even if you wanted to purchase, there wasn't any right technology which was available. The batteries which you could buy off the shelf were very, very expensive and still did not meet the performance which a Indian two-wheeler would want. Similarly, the motor controller was the same situation. The BMS was the same situation. So many things which we wanted, we believe that it is important to build a viable product into the market, or not just a viable, because in this case you're not just launching a vehicle into the market. You have to beat ICE. So you have to build something which people would want to buy, despite there is an ICE product into the market which is very stable, and you know that it works. It comes from a reputed brand. Now, why would I leave that and go for a startup product unless it is leagues better than what the ICE product is? And that's what we had to build, and that was not possible to build with what were available off the shelf.
This is Sain Jaiswal. Sir, as Ather early stage innovation was born out of IIT Madras, so how does Ather supports early stage IIT Madras startup that need pilot collaboration with the Ather Energy?
I mean, until now we haven't had. Actually, we had the opposite problem. We had not had many people come to approach us for any kind of help. I mean, we have not like if there is anybody who's building something, we would be very happy to work with them and give them a platform to work with us. But unfortunately, we had the opposite problem that we wanted, but people were not coming in. Very honestly, I don't think we did a amazing job of marketing, or like the first few years of our marketing were actually not very good. One thing which was, but the easy thing there was no real EV out there in the market. So marketing was easy. That's like India's first electric vehicle with touchscreen dashboard. That was more than enough for us to get people excited. But I don't think we were marketing experts back then. Our marketing was very, very niche. So we are only addressing very like what we call as Koramangala crowd, right? Like so we are only addressing the Koramangala crowd. We are not addressing a regular Indian. So and actually it took a while for us to understand that we are doing wrong in our marketing. We are actually not able to reach the masses because we are just too niche and too posh in our marketing. We have to bring it down to a level which relates to like a regular person in India. So yeah, but one thing was very clear that we have to we want to build trust from the start. So like one of the big question in front of us is that there are like very simply there is range. Now there is two ways you can define a range. So there is a testing agency called ARAI, which has a standard drive cycle with which they test any vehicle, and they will certify a particular range, and that's what is a certified range for you. But the drive cycle is so lenient that you will never get that kind of a range in your product. Similar thing happens with your mileage as well. The mileage which is shown which they put on the brochure is never what you get into on your product. So that's because the testing cycle is very lenient compared to what the real world cycle is. But we took a stance that we are not going to talk about the testing cycle, because while it's a bigger number, but the brand will lose trust. Because somebody will think that, okay, this vehicle gives me 80 kilometers, but then they ride and they only get 60 kilometers. So they will lose trust on the brand. This brand is not honest. So we actually took the call that, okay, we are going to only talk about 60 kilometers, because one thing which you want to do, if you are a young player, you are a startup, you are a new brand as well, you are selling a new technology. The last thing you want to do is not win the trust of the customer. So you want to build a very, very trustworthy brand, because the person has to go through a lot of other things while experiencing your product. They are taking a lot of risk while experiencing your product. So you might as well be honest to them. That was one very philosophical stance which we had taken when we did our first product launch.
Hi, sir. Hi. I just had a question about Ather's long-term vision on electric vehicles. Do you see yourself building a car as well in sometime in the future?
For now, no, because we think car market is very, very saturated and very, very competitive. No one like everybody in the world is actually losing money on probably except Tesla. Everybody is losing money on EV cars because it's so competitive. Not because their products are bad or anything of that sort. It has become, especially because of China, it has become so competitive that a lot of people are losing money. And unless we have a differentiation in that sense, what's the point of launching it? So maybe if we ever do it, if we have a four wheeler which is very India specific, maybe like, okay, bad example, but like maybe like a nano, only then it would make sense for us to do something of that sort. Otherwise, trying to build another car in a market where there are already like 50 different brands of EVs already existing, I don't think we can make any impact.
Yeah. Just wanted to ask you, see, you have disrupted the EV space. So there are a lot of things happening across the world in terms of autonomous capabilities in cars and stuff. So what I see, like see, cameras are more accessible. So what kind of, like plans you have to incorporate cameras? Because, like recently, a lot of things, like from safety. So people are talking about level 2, level 3, but, like a low cost autonomous or smart capabilities. Are you working on that?
No, so again, the challenge. I mean, we as a technology project, we keep doing it. We have done few what we call as ARAS, autonomous rider assistance system. Sorry, advanced rider assistance system. But I don't know when is the right time to bring it into the market. Two wheeler are much more complex than a four wheeler for autonomous driving. uh, the least you have to do is at least you have to balance the vehicle, which makes it very very complicated to make it autonomous. So while we have some thoughts about it, we don't know if when is the right time to bring it into the market, and will the customer value it enough, because it will add significant cost. In a car, the actually even cars, I don't know in India when will they be really viable. There are, yes, uh, some of the systems are good, like collision detection and all of those are good, but like autonomous is something which is I don't know if at least in the short term it will come in
Yeah.
India, even in cars.
Yeah, but autonomous is a very long trajectory of things. But at least from a camera point of view, like having an, like the cameras are much more cheaper.
No, see,
So,
and the technology is fine, but what do you do with that camera?
uh,
Like that's the real question. I mean, we have integrated cameras with our vehicle. I mean, internally we have done it, and it's pretty cheap. Like it's not actually expensive to integrate camera on a vehicle. But what do you do with it? Like, how do you find the real value with it? So we are still toying with some of the ideas, and there are possible options, but are they valuable enough? Would be either directly or indirectly will we make money out of it? Is something which we have to figure out.
okay.
I mean, actually, this has already happened. Like when the big players sort of got into the market, what they started doing is the simplest thing they started doing is, because they have money, they started doing discounting. So they said, okay, I can't match Aether's performance, but I will undercut them by making it cheaper and making it available to customers. So, but we actually stuck by our thought process. We said we are not going to drop the price of the product just to fight with them, because we fundamentally believe that we have a superior product. We would rather build more and more superior, more technology. So you don't play their game. You define your own game, because if you start play their game, then you are definitely going to lose. So if we also started building cheaper product and started fighting with them in cheaper product, you would definitely lose, because the cheaper you go, the technology differentiation is lesser and lesser. So there is no, you can't make a technology difference like in a cheaper product. So you want to define your own game and play that game, which is a technology game. You build products which they will not be able to build, and then you find a customer for it, and that's what we kept on doing. So we decided that we're going to not drop the product. We're going to continue to build a technologically advanced product, and continue to drop cost of those products as well. So first build superior technology and drop cost, rather than just just make it cheaper and cheaper. And that makes it very difficult, because now we have good technology and we have lower cost, which is going to be very difficult for them to catch up with. that's been our strategy. Yeah, I mean that's it's definitely there in our mind. Um, we believe that when we built the EV technology, a lot of these technologies can be used for the entire energy ecosystem as well. So yeah, I mean we would want to build something. What it is, when it is, that I'll not be able to talk about much. But yes, that's an interesting area which you want to work on.
Hi. So my question is that I have to have a deep knowledge of how did you design the product. So you spoke about the charger, right? So how for the design of a charger, there are certain things we have to consider about the output power we have to design for the combinations of the components. So similarly for designing your electric two-wheeler, so what was the starting point? Which product, like the battery you worked on the first, or how was the design? So what are the major challenges you faced? And like I also read through the product description, so it was like around the performance was 90 kilometers per hour. So how did you manage to grow from some so how did you manage to go from 30 40 kilometer speeds to 90? So I wanted to know more on the product design technologically.
No, I mean it's a decision of 30 or 90 or that was an easy one. I mean that is we just looked at the ICE vehicle and said we have to make at least that same performance or a better performance. The harder part was actually now designing the vehicle for the same. So I mean, it was a very convoluted journey. We on one side we were designing batteries, on the other side we were designing the BMS. Along with that, we are also designing our charger. Then we are designing our dashboard, and I'm like, it was a very organic way it would happen. All the engineers would sit together and they would discuss, okay, what are your specification, what is my specification, and that's why the first product took a long time to mature, because we were writing the spec sheet as we were designing the product. We will make something, it will fail. Then we realize, okay, we have not considered this. Then we'll write again a new spec sheet for it. So that's how the evolution of the design happened. It was a very, very iterative process. It went on for almost 5 years for us to come up with the right specification of the product.
So can you speak on like a major thing you have worked on, maybe a charger or something, like more technically, how did you solve the problem or something like that?
Become too deep
So because you're
conversation.
engineers here, so maybe we can try to understand the
No, I mean,
viewpoint.
see, I mean, it was, I mean, like, at least it took like almost 20 iterations for us to come up with the right charger design. Starting with like what kind of topologies to use to you build something, then you realize it doesn't give you the output or it's too expensive. Then you go around, change some of this. You talk to experts, some of the experts in the industry. Most of the time that also doesn't help. Then you go back and just use your own first principle to keep redesigning these things. So it's a very, very iterative process.
Hi, sir. As a CTO of Ather, you might be working with the lots of engineers, and I want you to list 3 traits of an early employee of Ather that which transition to the leadership uh, employee in your company.
I think firstly we would look at people with like first principles thinking. I mean, like, are you, do you know, if you know something, how it, do you know your engineering well, engineering fundamentals, do you know it really well? And that's when we would actually exclude a lot of industry people, because while they knew how to design something, but they didn't know why it was designed in a certain way. They had just some thumb rules and they would just design it with that. But we wanted people who understand first principles. If something is designed, why is it designed in a certain way, and if required, can you redesign it or not? So first principle thinking was very important. learnability was very important because you only know 10% of what you are supposed to know. The academia only teaches you engineering, which is probably only 10% of what you need. The rest of the 90% is what you have to learn in while being in the organization. So how good your learnability is very very critical, and collaboration, because product development is a very collaboration thing. You might be a very great individual contributor. You can very well, you can be an amazing, and we have had the such cases, people who are like amazing engineers by themselves, they can do wonders, but they can't work with anybody else. And if you can't work with anybody else, or you can't empathize with somebody else, then you're not you're not great to be part of a team. And then you you're not going to add to the you're not going to benefit the organization, you're just going to benefit yourself.
Hello, sir. Uh, Happy to see you. My name is Kadir. I am studying second year in ED department. Uh, how much is Aether interested in making a motorsports team? Like, will we see a Aether motorsports in Moto E, or will it be ready to help any other motorsports team that have been established by any Indian? So we don't see much Indian motorsports team. That too in electric vehicles, we don't see much. So how?
See, I mean, very honestly, motorsports is a branding and a lifestyle thing. It's not really. I mean, it from whatever I've heard, it's really really expensive to run a motorsports team. So only if you really need that brand value is when you should really do it. So today, given the cost, what it is to have a like a Moto G or or even a like Formula sort of a team, is just way too expensive to run that sort of a team. So we have no plans on doing anything on an international level.
And another question. So you are aware of the recent progress in LLMs like ChatGPT and Gemini. So how do you think that will affect automotive manufacturing? So if you are to start Aether today, how would you start it from today's technology?
Actually, it's very useful. I mean, a lot of the learnings can be cut short. For example, when I was talking about, let's say, like a spec sheet of a charger, you could actually ask ChatGPT or a Gemini or whatever, Claude or whatever, to write a spec sheet for you. And so it helps a lot in the, actually a lot in the 0 to 1 phase. It helps in a lot of knowledge aggregation. There will be knowledge in 20 books, 50 websites, which will immediately get aggregated and available for your usage. Similarly, code gen is obviously a lot easier now with AI. So yeah, I think there are a lot of things which one can do with AI.
Hello, sir. My name is Neer. My question is, what are you planning to do next? Where are you investing your time and money? As Ether, as you have a stable model and you have a large audience to target.
Yeah, so we're working on more two-wheeler models right now from the product standpoint, which is another scooter platform and a bike platform. These are the two things which we are working on the product side. On the technology side, everything from advancements in motor to batteries to battery management system and algorithm. These four are the key areas, and power electronics. These five areas are the ones where we are putting our maximum energy. To the idea is very simple. It has to either de-risk your supply chain, reduce your cost, or improve your safety. With these, one of these three things, these are three critical parameters for us to pick up any technology projects. And there are many projects which are running on in, like power electronics would have a GAN thing running. Battery will have a lot of safety related initiatives running. Motor will have how do you get rid of rare earth magnets, the sort of initiatives running. So these are the areas which we're working on.
Hi, sir. I'm Vinay. So my question is more towards the first 2 years where Ather was founded. So you mentioned that Ather has always tried to focus on having their own tech stack by themselves. How did you acquire that knowledge? I'm sure you had a lot of visions, a lot of ideas where you wanted to go with the product. But in terms of tech knowledge, did you try to gain it all by yourselves, or did you try to reach out to a professor, or did you hire someone with a lot of expertise in that field? So how did you go from, let's say, someone who had an idea to someone who had a tech heavy manufacturing product?
So it's a mix of things. Most of it was actually most of, as I said, the first principle thinking and engineers which we had with a high amount of learnability. They were the key because uh, people who could understand the tech could not understand manufacturing and vice versa. So it was very difficult to find anybody out there. So if you're a very if I find a industry expert, there's a very high chance they don't understand the technology aspect. So they would give suggestions which would not actually work for the engineers. And the engineers would not respect those people. So we had to let the engineers only learn for themselves. But yes, we were able to find some of the industry people who were good, who understood the first principles to work with us, and also the our design engineers learned a lot from them as well. And that's how organically, plus a lot of reading, a lot of sometimes you have to also draw parallel. Like if you learn something in the mechanical world, you want to like sort of say take that learning and apply it in everywhere. So there some of these things also, not everything has to be learnt from grounds up. You have to sometimes you use your own smartness as well. Sometimes books, articles, a lot of it, mix of lot of things came in handy. But in all of this, the most important thing was people with right mindset and curiosity and learnability. I think that was the most critical thing in all of this.
Yeah, thank you.
Hello, sir. I'm Abdullah Safwan. Before Aether, I saw electric vehicle that is very silent and quiet. We can't able to recognize in the road oil they are coming sideways without seeing that. But the quite interesting thing in the Aether was its sound. It's quite unique and attractive. How did you plan off that instead of going silent of like other electric vehicles?
So two things mainly. One is we didn't want it to be a silent vehicle. We really wanted it to be making some noise because it is too discomforting to have a very silent vehicle. There was also another aspect of if you are a automobile engineer, then there's something called a unsprung mass of the vehicle, which is how much weight is there below the spring. That is the unsprung mass of the vehicle, and that has a big impact on how your vehicle feels. And a hub motor is very heavy, and hence has a very high unsprung mass. So which essentially sort of messes up with your vehicle dynamics, and we didn't want that kind of a bad experience. So the 450 was supposed to be a very sporty product, and hence unsprung mass the very like 450 is a very low unsprung mass product out there anywhere in the market. And I think and hence we wanted to go for a mid drive motor to reduce the mass of the wheel.
Hello, sir. I'm Tejas. So, can EVs scale beyond a certain point? Like, can we enter into heavy-duty vehicles and ships and cargo planes and commercial planes? Is it possible to scale EV to beyond a certain point, beyond certain size?
Uh, yes, I mean it will take a while. I think it will start with shorter distances, and then eventually it will keep increasing. Battery energy densities are improving. The more energy dense the batteries are, the better it is for some of these long haul sort of applications. But yeah, maybe there will be some areas where we will not be able to always have EVs. Like I don't know if like large cargo ships, can they be EVs? I'm not sure about it. So that is one area which which I am not 100% confident. But as the technology evolves, it's very much possible.
Hello, sir. Mahesh here from ED 27, a super junior maybe. Yeah, I guess 15 years. Yeah. So, sir, my questions are technical related. So, one question is related to the Indian driving conditions. Sir, as you rightly pointed out, like generally for two-wheelers, the expected range or driving range is around 30 to 40 kilometers. But sir, range anxiety comes into picture when we plan, let's say, one day long trips. Only then range anxiety comes into picture. Sir, for that, is Ether doing anything to come up with a good range estimator, considering weather conditions, considering driving behavior, and all other parameters? That is.
Yeah. So it's also very tricky. So actually, so firstly, to answer your question, what we are doing is we are actually building up these fast charging stations across the highways. We are putting up some of them in highways as well, and definitely within the city, but also starting to put some in some of the more utilized routes, like a Bombay Pune or Bangalore Mysore. I think Chennai Pondi. These sort of regions is where we are starting to put on the highway as well. But range, while the complex thing there is that most people do not want. While as engineers we understand that range can be uncertain because based on the terrain and various other conditions, most usual customers don't understand that. And if you give them that answer, that hey, in this time you will get 50 kilometer and this time you will get 20 kilometers, they actually get scared. They think something is wrong with my battery. That's why I'm only getting 20 kilometers. They don't realize that okay, I'm going uphill, and that's why I'm getting only 20 kilometers of range. So we have seen actually we built that kind of a feature, and then we realized that customers are getting scared. They suddenly feel that there's something wrong with their battery, and we actually rolled back that feature because we didn't want people getting unnecessarily panicked about their battery.
Okay, got it, sir. But okay, yes, sir. Point agreed. But sir, won't it be more assuring for the driver if he gets to know is he within a charging station vicinity or not?
Yeah, so that you get. You have all the charging stations on your map. You can just check what is the distance.
Got it, sir. Just one more last question, sir. Sir, as Ether offers 70 to 8 guarantee on battery packs, like 70% SOH for 8 years. Sir, what about after 8 years? Is Ether planning for battery recycling? And
so there are many recycling players in the market already. We by ourselves we have not planned for recycling, but recycling will happen. It's by regulation itself. Recycling has to happen. So we will have to recycle those battery, but it is not whether Aether does it or not. That's to be seen in the future.
Okay, sir. Yes.
Nice, last question.
Hello, Swapnil. So I'm Chris, and I'm from Engineering Design Branch 23 question. Okay, so I have a few questions. So the first question is like, Ather is also known as the Tesla of two-wheelers in India. And India also is like talking about how they will revolutionize EVs and indigenous technology and stuff. So one question is, why isn't there any high performance electric vehicle? So like along the lines of the D-Max or the Lucids or even the BYDs of this world. So is it like because of the traffic conditions and road conditions, or like the different weather conditions we have to face, like higher humidity and temperatures and stuff, or like is it because we do not have a market for these high performance vehicles that the Indians are like interested in?
As you said, forget about EVs, how many D-Max do you see on the road? Right, like even the ICE D-Max, you don't see many of those on the road. So that answers your question. There is not enough market for pickup truck sort of. That's only a very American concept. India, like you don't have enough roads to like drive a pickup truck. So yeah, that's the reason.
Okay, so the other question is, you mentioned that the new platform and plant architecture will reduce the assembly time by around 15%. So beyond just the production speed, what other industry 4.0 technologies are you most excited about implementing in the new Aurangabad facility that wasn't possible in the previous facility in Hosur?
Yeah, so no, everything was possible in Hosur. Just that we chose not to do it. But a lot of it is actually manufacturing. A lot of people feel is about technology, but very honestly, the first principle of manufacturing is just industrial engineering and discipline. Like you have to get that right. If you get that right, you can squeeze out assembly time. You don't need any automation necessarily. You can squeeze out a lot of your assembly time by just proper industrial engineering, doing proper industrial engineering itself. And but certain things like very high amount of traceability, flexibility in production plans, like for you want to build a red color, then you want to build a blue color, then you want to build a green color. That requires a very high amount of integration in your systems, and that's those are the sort of things. Plus a lot of traceability where you every process parameter will capture it so that it can be used for further optimization of the process. These are the things which we are doing it in our Aurangabad plant.
One more question. So, like recently in places like the US and even some European places, so there is one trend about advanced air mobility or like electric aircraft, so eVTOLs and that sort of stuff. Yeah, even in our own research park, we have this e-plane company. So, like, what are your views on the advanced air mobility trend in India?
No, I think it will be very interesting. I think it has a very high potential to be successful, much much better than probably the success which helicopters had in India. I think eVTOLs have a very high possibility of being successful in India, and we have the ability to build it as well.
Okay, so let's say if you're interested in eVTOL, so like what exactly do you think Ather has to offer in this market?
All the technology which is required to build an eVTOL, except the propulsion, is something which we have, and so we have to build the rest of it.